Hi, my name is Harini, and I'm presenting our work on semantically grounded, context-specific model evaluation. So evaluation is really important because it determines what systems are considered state-of-the-art, how we understand system strengths and limitations, and the areas we target for improvement. As a result, evaluation has a broad impact on research agendas and values in machine learning. Because of this, we really need evaluation paradigms that surface harm and reflect actual user needs. As a specific example of where current evaluations fall short, consider content moderation. Lots of research has shown that different online communities deal with very different types of harassment and enforce widely different rules and norms. For example, this paper grouped subreddits into clusters based on the types of rules they enforced. As shown in the table, they found that some subreddits moderate things like comments mocking the concept of a safe space, while others do not. Some moderate attempts to be funny or sarcastic, while others don't. And there are hundreds of norms like this that differ widely across communities. At the same time, moderation is pretty taxing, and there are increasingly more machine learning-based tools out there that claim to be able to help partially automate the process of moderation, like this one called Perspective. But how would someone in a particular online community figure out if one of these tools would make sense to use given the rules and norms of their specific context? Typical evaluations might be able to tell us things like the model's accuracy or general robustness, which are certainly useful things to know. But they're not enough on their own because they don't capture many of the other things that matter to people in a particular context. For example, it'd be much harder for a moderator to ask the question, is this moderation model able to flag comments mocking safe spaces with existing evaluation methods? That's because this requires understanding a semantically meaningful concept, which can't be easily formalized or described with low-level features. And it stems from users' personal knowledge about the types of things that are important in their context. So we designed the system Kaleidoscope to fill this gap and facilitate model evaluation that achieves these goals of being context-specific, semantically meaningful, and user-driven. It's made up of an underlying workflow and methodology as well as an interactive UI that implements it. Kaleidoscope's workflow has three parts, starting with identification, where users identify a few exemplars of a semantically meaningful concept. So taking a content moderation example, they might identify the single comment, "Immigrants don't belong here," as an exemplar of a xenophobic attack. Then they would generalize these exemplars into a larger diverse set of examples representing the broader concept of xenophobic attacks. Finally, they can specify their expectations of good model behavior with these concepts and test whether they hold. So here the user could specify that they expect xenophobic comments to be moderated and test how well the model meets this specification. And when I refer to examples and data here, it's unlabeled data intended to come from the user's context. We built an interactive system to facilitate this workflow, where the overall layout looks like this. On the left, users can construct example sets that represent meaningful concepts. The middle is a projection of all of the examples in the data that's utilized throughout the workflow. And on the right, they can specify and run tests about model behavior using the defined example sets. So let's say I'm a moderator of the news subreddit, and in this subreddit, comments insulting moderators are not allowed. So I want to ask the question, how well does this moderation model deal with those kinds of comments? For this example, the system will be seeded with data from my context of r/news. As a heads up, in a few slides, I'll be showing screenshots with real data, and many of the comments can be quite offensive. So we start with the identification stage. I might already have a particular example in mind based on something that I've seen, which I can input directly to seed the example set. If I didn't have a specific example, though, I can still find one by exploring examples using a keyword. Here, I'm using the keyword mods. Just aiming to find a few relevant exemplars of the concept and use those to seed the example set. Once I do that, they're now part of the insulting moderator's example set that's been defined above. In the generalization stage, a user can expand those few examples into a larger, diverse set of examples representing the higher level concept they have in mind. The way this works is through iteratively retrieving semantically similar examples from the data based on a distance metric in a learned embedding space. So how this would work in the tool is we first select the exemplars we added. What appears down below then are other examples from the data that are most semantically similar to those that I've selected above. The results are grouped into 3 clusters, and the projection plot shows us where these clusters appear relative to other examples and the top words in each cluster. By skimming the examples and this information, we can quickly try to get a sense of the types of examples in each cluster. Depending on our mental model of these types of examples, we might decide to only add certain examples or only certain clusters, but in this case, let's say we think these are all relevant to the concept. We can select all and add them to the insulting mods example set. At this point, this process keeps iterating. Relevant examples get added to the example set that updates the similar examples based on the new selection, and then we add relevant examples or clusters again, and so on. And we can repeat this just a few times to build up a pretty large example set. Here, after just a few iterations of this process, I ended up with 116 examples that I feel represented the concept of insulting moderators. In the specification and testing stage, users can use the defined concepts to make their expectations of good model behavior explicit and test how well the model meets those specifications. We define a bunch of different behaviors users can specify, including desired model outputs or desired output shifts between two distributions. And our paper has more details on how we organize and formalize these different behaviors. In the interface, this is an example of creating a test to specify that comments insulting moderators should be flagged by the model. That's what I'm specifying here with desired model behavior. After I run this, I can see that the model only gave 32.8% of that example set a moderation probability above 0.5. The output also shows the probability distribution and specific examples that the model recommended should or should not be moderated, which I can filter to see, for example, if the examples with a lower probability are actually less severe than the examples with a higher probability, or if the model is paying attention to unwanted correlations or ordering these examples in a way that seems arbitrary. We can also test other types of behavior. So for example, we can create a test saying that xenophobic comments should be moderated, even if they have the phrase LOL JK at the end of them. This would be what we call an instance level invariance test, since we want to check that model behavior doesn't change after applying a transformation to each instance. We can choose from a range of transformations, but here I'm just defining one that adds the phrase LOL JK to the end of each example. After running it, this plot shows us how much model predictions changed after applying the transformation. So on average, predictions don't change, but there are several examples for which predictions either become significantly more likely or less likely to be moderated after adding LOLJK to the end of the example. And here I'm filtering to show examples that used to have a very high probability of moderation, but post-transformation have a very low probability, which in many contexts you can imagine would be quite problematic. I'll end by talking about some insights from a study we did with Reddit users and moderators who used Kaleidoscope to evaluate publicly available moderation models for their context. I'll highlight just 2 insights here, but please see our paper for the complete analysis. So first, we found that the generalization process drew out participants' implicit or personal knowledge about what was important in their context. For example, one participant intended to create an example set representing racist comments. But while looking at the retrieved similar examples, she realized that to her, there was a distinction between comments that were outrightly offensive and those that disguised racist sentiments behind long arguments. And she wanted to examine each of these types of examples separately. So she ended up creating 2 example sets representing these 2 subsets. This is the distinction that she probably wouldn't have been able to identify or formalize upfront, but rather the exploratory nature of the generalization process helped to draw out that implicit knowledge and allowed her to explore the model behavior on these important concepts. And we also found that running tests revealed important context-specific trade-offs. For example, one participant created an example set representing comments about torrenting and piracy, which should all be moderated in r/movies, a subreddit they moderate. The test found that the model was really bad, only flagged around 7% of that example set. But when they created another test focused on personal attacks, it flagged 96%. So the participant reasoned that this wouldn't really make sense for r/movies, but in another subreddit I moderate, it's just daft arguments, blatant insults, stuff this would catch. In other words, they were able to relate these tests to data distributions in different contexts in order to reason about appropriate use cases of the model. We performed another comparative evaluation that I didn't go through today, but together our insights there and through our user study demonstrate that Kaleidoscope allows users to ask semantically meaningful questions about model behavior that would be difficult or impossible to answer with existing evaluation methods. And rather than being aimed at machine learning experts, it enables users with deep personal or implicit knowledge about their context to make their expectations explicit and to understand model strengths and limitations in terms of concepts that are important to them. Please check out our paper for more details, and thanks for listening.